Hello, I'm Michael Agard, and thank you very much for watching this short video on how to determine the statistical significance of an A-B split test. Today I'm going to go over three basic factors that are essential to establishing the reliability of your test results. These three factors are confidence level, conversion range, and sample size. I'm gonna do a basic introduction here, but I want to go over all three factors because, one of the big mistakes I see marketers making is either to not focus on any of these three basic factors or to focus only on confidence level. And both those approaches are flawed because you really need to be aware of all three factors in order to perform valid experiments that provide true and lasting value to your online business. Because the whole point of performing an A-B split test is to get answers so you can base your decisions on data rather than gut feeling and guesswork. So if you can't rely on your data, then, well, it really defeats the purpose of performing the test in the first place. And what test validation is all about is finding out whether the tendencies you're seeing are a reliable representation of how the variant will perform, or whether the tendencies are simply random. And that's where the three basic factors I mentioned before come into the picture, because they help you to determine the likelihood that, for example, A is in fact better than B. And a statistically significant test result is one that in all possible likelihood indicates that we have an actual winner. Okay, so let's look at the three factors one by one, and we'll start with confidence level. So, statistical confidence measures how many times out of 100 that a test result can be expected to be within a specified range. A confidence level of, for example, 99% means that the results will probably meet expectations 99 times out of 100. In other words, a 99% confidence level means that there's a 1% chance that number's off. And a confidence level of, let's say 60% means that there is a 40% chance that the number's off. So, if you stop a test at, for example, 60%, you are willing to accept that there's a 40% risk that your numbers are off. Confidence level is by far the most commonly used and known factor, and it is an extremely important factor, but it is in no way enough to guarantee reliable results. You need to look at the other factors as well. So let's move on to conversion range. Conversion range is a bit more complicated, but I'll try to explain it as simply as possible. Well, the conversion range shows you the range within which the actual conversion rate may lie. And you'll find the conversion rate for each variant over here in the screenshot. And so the small plus minus sign in the number you see here beside the conversion rate is what you call the standard error. In this case, the standard error is 1%, and it means that the conversion range for the control variant, for example, the control here, is 7.95 plus minus 1%, which again means that the actual conversion rate is somewhere between 6.95% and 8.95%. And for variation 1, the standard error is also 1%, which means that the conversion range is from 10.08% to 12.08%. So the conversion range can be described as the margin of error you're willing to accept. This means that the smaller the conversion range, the more accurate your results will be. And you can say that as a rule of thumb, if the two conversion ranges overlap, you'll need to keep testing in order to get a valid result. In this case, if we add the standard error, which is 1%, to the lowest conversion rate, that of the control, and subtract it from the highest conversion rate, that of variation 1, we'll see that the two ranges don't overlap. So this is a good sign that variation 1 will in fact perform better than the control. Alrighty, so I'll pick up on this again a little bit later, but let's move on to sample size. Sample size represents the number of visitors that have been part of your test and how many conversions they have performed. The reliability of your data increases as you increase the number of data points. In other words, the larger the sample size, the more reliable your results will be. Well, and this is pretty much common sense that the more people you include in a test, the more representative the results will be. So there's a correlation between sample size and conversion range. And as your sample size increases, your conversion range will decrease. So here's an example of a test with a small sample size of 73 visits and 8 conversions. Here you'll see that the conversion rate for the control is 5.88 plus minus 5%, and it is 15.38 plus minus 7% for variation 1. So this means that the actual conversion rate for the control is somewhere between 0.88% and 10.88%. And for the variation, it's somewhere between 8.38% and 22.38%. So it really doesn't take a rocket scientist to see that these ranges overlap quite a bit and that you would need a larger sample size in order to get reliable results. And therefore, concluding anything at this point involves quite a risk. But what often happens is that marketers get overexcited about results like these and jump to conclusions and assume that they have a winner, when in fact all that they have is a 91% chance that the conversion range for the two variations are accurate. Okay, so this moves us on to the question: how large a sample size do you need in order to achieve significance? Well, in theory, you can't define the number. It depends completely on the individual test. But as a rule of thumb, you can say that the bigger the difference in performance is between the two variations, the smaller the sample size you will need in order to get a reliable result, and vice versa. So, if you have a dramatic difference in performance, you'll need a smaller sample, and if you have a minor difference in performance, you'll need a larger sample. So in my experience, a lot can happen within the first 100 conversions. So my rule of thumb is to get at least 100 conversions before I conclude anything. And notice that I said conversions, not visits. Also, a great tip when you're trying to validate your test results is to look at the graph that graphically depicts the development of the test. If you see a lot of fluctuations, as is the case here in the first example, well, then that's a sign that you need a larger sample, or that there might not be a significant difference between the two variations. On the other hand, if you see a nice clear tendency that one variation is outperforming the other, then that's a great indication that your results are reliable and that you'll find an actual winner. But be aware that fluctuations are natural in the beginning of a test period, because when the sample size is small, small changes will have a large impact. Alrighty, so let's do a quick summary and get some guidelines here. So, whenever I perform a test, I try to get as close to a 99% confidence level as possible. I want a sample size of at least 100 conversions before I start concluding anything. And I want to get a conversion range or a standard error of less than 1%, plus minus 1%. Also, I look at the graph that depicts the development of the test, and I look for fluctuations or diamond shapes, as you would call them. But I think the best tip I can probably give you is don't jump the gun. I mean, it's very difficult not to jump the gun, and I mean, it's so easy to get overexcited over premature test results, and you want results, and you're so excited to see a test go well. But I mean, I'm speaking from experience, and having done this so many times, you can really backfire if you stop a test before you actually have a statistically valid result to base your decisions on. And I hear a lot of marketers complain that their testing tools are off or don't work. But in most cases, it's not the testing tool that's the problem, it's the person interpreting the test data. And as is the case with so many other things, the tool is only as good as the person using it. Alright, cool. Now you are familiar with the 3 basic elements, and you know how to determine the statistical significance of your test results. So now it's time to get cracking on some more experiments. And I'd just like to say thank you for watching, and I'll see you next time.